Alright, sorry guys. This is actually one more slide that I forgot to put in the last video. So that is not the last video. This is going to be the last video. So bear with me. It's only going to be very quick, very brisk. I would just basically like to sum up on CRISPR being the ideal technology for editing. Why? Because a lot of people basically has touted or basically has confirmed via research and a lot of work, okay, that CRISPR seems to be a method which is simple, cost saving, and also fast for editing. So let's have a look at why it is ideal for editing technology. First and foremost, it has high potency and specificity, especially in terms of cleavage or cutting efficiency. We have seen that the guide DNA basically in a lot of papers, okay, if you're interested about it, go and read some of the CRISPR paper. They do cut at the specific site whereby the guide RNA carries it. Secondly, it has broad in vivo and ex vivo applications. This is actually very useful, whereby we know that in gene therapy, with the use of different viruses and also non-viral vectors, there are certain hinder or disadvantage in use of either in vivo or ex vivo. The same goes for stem cell, because we know that usually it is for ex vivo, not so much of an in vivo, but for CRISPR, it could be used for both. The third one, it is, like I said earlier on, it is a simple editing tool whereby you only need your guide RNA plus protein, or you can have your tracer RNA. So they have the ability to scale and optimize at speed and a very fast rate as well. Next, it has the potential as a one-time curative treatment. So this has been monitored in dragonfly in mouse. It hasn't been tested on human yet, but on the embryos, it has been quite good, high efficiency, able to address any site in the genome. So far, there is no I would say there is no problem getting to any target site in the genome. Some of the target site is quite hard to reach by gene therapy or even stem cell therapy. It is able to also multiple target DNA sites concurrently, whereby we know from some of the diagram, and this also leads to the last point of multifunctional, whereby you could basically do some rearrangement even. And of course, again, like I put over here, it has a multi-purpose or multi-function, whereby you could delete, you could insert, you could repair, you could rearrange, you could indel, you could do swapping, you could do a lot of things by using CRISPR. So having said that, okay, probably you can just take a look at the three technologies side by side: gene therapy, stem cell therapy, and also CRISPR, and probably have a look at how they actually could be used in some of the disease. Alright, so that's it. We'll move on to the next chapter next week.